All right. In this video's lesson, we're finally going to get to see some of the cool stuff that your graphing calculator can do for you. And we're going to do that by talking about what are called matrices. And really, matrices are what we use to write systems of equations in a little bit more simple form. So that's why that they are kind of combined into this one unit. Is we've already talked about solving systems of equations by graphing, by elimination, by substitution. We're now going to have the chance to talk about them in one additional way, which is that we'll be able to solve them using our graphing calculator and using matrices. Okay, so first we need to talk about a matrix and kind of everything that goes into it. We'll start by talking about an element. So an element is each entry in the matrix. So every single entry in the matrix is going to be what's called an element. As an example, when we talk about an element, if we were to say A1, 2, this would be the element in the first row and the second column. And so we use this naming convention where A basically tells you which matrix it's from. So we'll have matrices that will be called matrix A, B, and so on. So A tells you what matrix it's from, and then the subscript of 1, 2, not to be read as 12, but to be read as 1, 2 separately, tells you that you are in the first row and second column of that matrix. So the order of a matrix is the way we describe the size of the matrix. And we do that by listing the number of rows by the number of columns. And again, this X doesn't mean multiplication. It means that that is kind of an arrangement that you've made. So the number of rows by the number of columns. So let's see an example of talking about the order of matrices, and we'll talk about the elements as well. So for example A, we've got this matrix. It's just got a single element. It's just got the number 5 in there. That means that for the order of the matrix, it is one row by one column. So this would be a 1 by 1 matrix. And if you wanted to describe the one element in there, you could say that element A11 is equal to 5. For example B, we have one row and we have 4 columns, so this would be a 1 by 4 matrix. Let's say you wanted to talk about this third element, so where it says 0, then we would say that that is the element A13. In other words, it is the element in the first row and third column, so A13 is equal to 0. All right, for example C, we now have 3 rows and we have 2 columns. So again, that's 3 by 2. So this would be an example of a 3 by 2 matrix. And let's say we wanted to talk about this element right here. That element is in the second row and the first column. So that would be A21. So that would be the element -2. Now, these matrices didn't have names. That's why I used A for each of them. Later on, when we start to name our matrices, we'll have to be a little bit more careful about whether we use A or B. But again, since they didn't have names, I just left them all as A. Next, let's talk about the equality of matrices. So how two matrices can be equal to each other. Number one, they have to have the same order. In other words, the two matrices have to be the same size. You can't have a 3 by 2 matrix equal to a 2 by 1 matrix. So they have to be the same size. Step 2, all of the corresponding elements must be equal. So the element in the first row, first column of one matrix has to be equal to the first row and first column of the second matrix, and then so on and so forth. And we'll see an example of kind of how that works. Now, both of those have to be true, otherwise the matrices cannot be equal. So even if they're the same order and the same size, all their elements have to be equal to each other. And even if all the corresponding elements that they share are equal, they have to be the same size in order to be equal. So it's important to make sure that both of those are satisfied in order to have matrices which are equivalent. Okay, So let's see how we can use that to solve some simple equations. In order to show that these two matrices are equivalent to each other, and it does say that they are equal, that means that this first element in the first row, first column, has to be equal to this element, first row, first column. In other words, x minus 4 must be equal to 0. And then that's a pretty easy equation to solve. That tells us that x has to equal 4. The same must be true of this element 5. It must be equal to 3z minus 1. And if you wanted to write it in the other order, that would be okay. So to solve that, add over the 1, and then divide by 3 on each side. So z must be equal to 2. So we also know that 2y plus 1 has to equal 1. So then subtract 1 on each side, and then divide by 2, and you'll get that y must equal 0. And then finally, we know that 8 must be equal to 3w minus 7. So then add over the 7, and you get 15 equals 3w. And then divide each side by 3, and w must be equal to 5. So this would be a good chance if you wanted to practice this on your own. To work through example B, go ahead and pause the video, and then we'll check our work in just a moment. All right, let's see how you did. So x plus 4 had to equal 0. So then subtract 4, and x should have been equal to negative 4. All right, for the next one, 5 had to equal 3w minus 4. So you would have added over the 4, divided by 3, and w is equal to 3. Next, y plus 1 should have been equal to 5, and then just subtract 1, and y is equal to 4. Finally, 8 must be equal to 2z minus 6. So then add over the 6, divide by 2, and 7 is equal to z. All right. So here's where we'll start to talk about how you can actually use matrices to solve systems of equations. And so we first need to talk about what are called augmented matrices. So augmented matrices is where we write the coefficients for each of the variables and the constants that they're equal to. In other words, all of our equations need to be in what's called standard form. So standard form, just as a reminder, is where you would have all of your variables on one side, all of your constants on the other. So let's take a look at kind of how this works with example A that I've got right here for us. And I do believe this was one of the questions that I updated. So if you do not have the updated notes, just copy this one down in your notes next to whichever one I had right here. And this will be the first one that we will use. So when we write an augmented matrix, we're only concerned with the coefficients. If there's not a number in front of the variable, remember we assume it to be a 1. So I'm just going to fill in those 1s for each of those variables. So to write our matrix, what we're going to do, let's just take this first row. Is our first coefficient was 1, our second coefficient was also 1, and our last number on the other side was 4. For the second equation, our first coefficient was 2, our second coefficient, be careful, was negative 1, and our last coefficient, not really coefficient, I should be more careful, our constant is 8. In other words, we've got a 2 by 3 matrix, and then conventionally, when you write an augmented matrix, we will put kind of a dashed line in between where our constants and our coefficients are separated. So in other words, where the equals sign is, we'll typically put this dashed or dotted line to show that they are separate from each other. Okay, let's take a look at B, a little bit larger system of equations. In fact, this one has 3 variables, and so that's why you've got 3 equations that we're going to be using here. Now for the first equation, it's important to make sure that every single variable gets a coefficient. even if the variable isn't in the equation. In other words, for this first equation, where it's 5y minus 3z is equal to 9 and doesn't have an x variable, it's important to make sure that we write that as 0x plus 5y minus 3z is equal to 9. So even though x wasn't in there, we need to make sure that the 0 is. And so that'll actually be the first number we'll write in our augmented matrix is 0. And then we'll continue with the rest as normal. For our second equation, we actually have all of the variables. It's also important to make sure that they are in order, x then y then z. So that would be -4, 8. Remember, z is -1, and then 4 for our last number. Now this third equation did have a typo in it. I meant to catch that when I was updating it, but make sure that that w is in fact a y, and that way we can write 3, -2, 6, and 13. And then once again, where the equals sign was, we'll put in that dotted or dashed line, and then we'll draw in our other bracket for our matrix. Okay, so that's what you're going to need to do to set up a matrix to be able to put it into your calculator, is we'll have to convert it from its equation form into its matrix form using an augmented matrix. Once we've done that, here are the steps to solving those systems of equations. So step number 1 is we're going to enter the matrix into the calculator, and then we'll hit second mode to quit out of that screen, and we'll be able to see all these in just a moment. The way you get to that matrix screen is you'll hit second and then this x to the -1 button. And then you'll move over to the math menu where you'll choose an option, which is usually option B. It'll be called RREF. And just so you're aware, RREF stands for Reduced Row Echelon Form. Not something that you need to remember, but if you're wondering what it stands for, that's what it is in place of. Step number 4, you're going to go back to the matrix menu to choose the matrix that you want to use. Make sure to close your parentheses, press enter. And then at the very end, I'll ask that you write down the augmented matrix that was left and then your solution as an ordered pair. Okay, so let's solve each of these using our reduced row echelon form, first writing our augmented matrix and then our solution. So first step is going to be to put this into an augmented matrix. So just like we were doing above, let's go ahead and fill in those coefficients. So 3, 2, and then 4, 2, -1, and 12. All right, so let's talk about how to put that into your graphing calculator. So the matrix button is right above this x to the -1 on the left-hand side of your calculator. Now, when you go in there, depending on if this is a new calculator or one that's already been used, you may or may not have some matrices already in there. If you ever want to delete a matrix, here's what you'll do. Let's first quit out of this screen, so second mode to quit out of that screen. And then we're going to go to the memory option, which is above the plus sign, so second plus. We're then going to select option 2 for memory management and delete. Option 5 of that list is matrix, so if we choose option 5 and press enter, it will then tell us what the matrices are that have been programmed in. To get rid of a matrix, just press the delete key, and that will delete whatever matrix you have selected. So just to start with a fresh slate, I'm going to go ahead and delete all of my matrices, and so now I shouldn't see anything in that matrix menu when I go back to it. So if I hit second mode, once again to quit out of that screen, and then second x to the -1 to go back into the matrix screen, I should now no longer have matrices in there. So now we need to put some in. So let's go over to edit, and let's choose a matrix to type it in as. Let's just choose matrix A. It's first going to have you determine the size of the matrix. So this is where the order comes into play. The augmented matrix that we wrote down is a 2 by 3 matrix. So we will type in that it is 2 by 3. Once we've done that, notice that it now has a matrix which is the same size as your augmented matrix. So now we can go ahead and start to type in our variables, or our numbers. So the first was 3. Once you press enter, notice that it moves you from left to right across the row. So if I type in the number 2 and press enter again, notice again that it moves me across the row. Now, when you get to the end of the row, it will then move you down to the next line. So just be careful, understanding that the enter key will move you across rows, not down columns. Okay, so we've got our matrix typed in there. We'll just need to double check and make sure it all looks okay. So 3, 2, 4, 2, -1, 12. Okay, so now that it's typed in, we're going to quit this screen. We're then going to go back into the matrix screen. It's a second matrix, over to math, and then option B is RREF. Usually it's easiest to scroll up from the bottom a little bit quicker, and we'll choose that as our option. Now, once we have RREF, we now need to say what matrix we want that for. So we need to go back into the matrix screen, not over to edit, but just under names, selecting option 1 for matrix A. We'll then close our parentheses and press enter, and it's going to give us a new matrix, which I will write down over here, which I will go ahead and write it in this form. If you would like to do the same, that would be great, which is that we used reduced row echelon form to convert that matrix to being 1, 0, 4, and 0, 1, -4. Now, notice that really all that did was give you another matrix, but actually, if you think about what it did, let's convert this matrix back into equation form. So that would be the first line is 1x plus 0y is equal to 4. And then the second equation is that 0x plus 1y is equal to -4. Which then, if you think about it, really what that's telling you, x plus 0y is just x. In other words, the first row is telling you that x equals 4. The second row, same idea, is telling you that y equals -4. So our solution is actually going to be the point 4, -4. All right, let's take a look at another example of this. So let's first, on example B, write our system of equations in our augmented matrix. So the first line should be 2, 3, 2, and 15. The second line should be 1, -1, 2, and 5. The third line should be 1, 2, -6, and -26. Okay, so let's go back to our matrix screen, second x to the -1. Let's go back over to edit, and I'm just going to make this matrix B. So matrix B has 3 rows and 4 columns, so it is going to be a 3 by 4 matrix. And then typing those numbers in, 2, 3, 2, and 15. 1, -1, 2, and 5. And then finally 1, 2, -6, and -26. Notice that when you type those into the calculator, that dotted or dashed line doesn't need to be put in. You just put the numbers in order like you see them in the matrix. So let's just again double check and make sure everything looks good. So 2, 3, 2, 15, 1, -1, 2, 5, and 1, 2, -6, -26. Perfect. So let's quit out of that screen. Let's go back into our matrix menu. Once again, we'll go over to math, up to reduced row echelon form. We'll then go back into our matrix menu, select our second matrix this time, so matrix B, and press enter. And we get a solution. So we'll go ahead and show what this is in reduced row echelon form first. So that would be 1, 0, 0, -2, 0, 1, 0, 3, and 0, 0, 1, 5. So the same idea still applies. I'm not going to write out the entire system of equations from this, but remember that the first column is x, second column is y, and third column is z. And so our first column, our first row basically tells you that x is equal to -2. Our second row tells us that y is equal to 3, and our last row tells us that z is equal to 5. When you write these as a solution, rather than writing them as a point, we're going to write them as what's called an ordered triple, which is the same idea. You are just putting commas in between 3 numbers instead of just 2. Okay, let's take a look at just a couple more examples to see some kind of different things that'll happen occasionally, and then we'll take a look at 2 real-world applications, and that'll be it for this video. All right, so for example C, we've got x minus y plus 5z is equal to negative 6 for our first equation, and then so on. Let's go ahead and first write these into an augmented matrix. So 1, negative 1, 5, and negative 6, 3, 3, negative 1, and 10, 1, 3, 2, and 5. Okay, let's next go ahead and put those into a matrix. So go into the matrix menu, over to edit. I'm just going to make this a new matrix, so I'll make it matrix C, and it needs to be 3 by 4. So 1, negative 1, 5, and negative 6, 3, 3, negative 1, and 10, and then 1, 3, 2, and 5. Again, make sure that you've typed that in correctly, because if you type anything in wrong, it's obviously going to give you an incorrect solution. So it's important to make sure that you don't make any typos. Let's go ahead and quit once we've done that. Back to the matrix screen, over to math, up to RREF. Oops, went one too far. And then we'll choose our matrix. So that would be matrix C. Close our parentheses and press enter, and we get this as our solution. So again, that was using RREF. Here was the matrix that we got: 1, 0, 0, 1, 0, 1, 0, 2, and 0, 0, 1, negative 1. So then our solution to that system would be the ordered triple 1, 2, negative 1. All right, one more example of this just to make sure that you have it down, and then we'll talk about the 2 examples where we've got some real numbers or some real problems in there. So for our first row, 1, negative 1, and 1. Second row would be 2, 3, 1, and 2. And third row, be careful, 3 for x, 2 for y, 0 for z, and then 0 for our constant. So be careful with how you write that last equation, making sure that you do include a 0 for z, otherwise we won't get the right answer. So let's go back to matrix, over to edit. We'll choose option 4 to make a new matrix. Again, a 3 by 4 matrix, and we'll go ahead and type in those values. Okay, so then double checking, looking it over, 1, negative 1, negative 1, 1, 2, 3, 1, 2, 3, 2, 0, 0 looks great. So again, we'll quit out of that screen, back to the matrix menu to find RREF, back into the matrix menu once again to select the matrix that we'd like to use, which is the 4th one, and then we'll close our parentheses and press enter. Okay. So let's go ahead and write the reduced row echelon form for this equation, or for this matrix, I should say. So that was 1, 0, negative 0.4, and 0, 0, 1, 0.6, and then 0, and then 0, 0, 0, 1. All right. Now, one thing that we need to be careful with, and I'll explain why in just a moment, but we are not going to say that the answer to this system is 0, 0, 1. And here's the reason why. If you take a look, the first row actually is not saying that x is equal to 0. What it's saying is that 1x minus 0.4z is equal to 0. And the second row is saying that 1y plus 0.6z is also equal to 0. Now there's really nothing wrong with those two equations. Those could in fact be true. Here's the problem, is on the last row. It's telling you that 0x plus 0y plus 0z is equal to 1. In other words, the last row is trying to tell you that 0 equals 1. And we all know that that cannot be true. You cannot have that 0 is equal to 1. And if that's the case, then what we're going to have to say is that this system of equations has no solution. Now, in a similar way, you can also have an infinite number of solutions. So if you remember back to our kind of very first day of this unit, we talked about the different types of solutions, whether you got no solution, one solution, or infinitely many. Obviously, one solution is where you end up with an ordered pair or an ordered triple. No solution is where you end up with something like this. The last thing that you could possibly have, and I'll just write it as a smaller matrix kind of over here to the side, is you could end up with a matrix, and I'm just going to write it as a 2 by 3 matrix, that looks something kind of like this. You could have 1, 0, 3, and then something that said 0, 0, 0. So if the last row is all zeros, where this would be true, right, because 0x plus 0y does in fact equal 0, because 0 does equal 0, in that case, you would write that there are an infinite number of solutions instead. So when you have these kind of different ways of writing the system, if the last row is a false statement that 0 doesn't equal 1, then that's going to be where you'll write that there is no solution. If the last row, though, is in fact a true statement, like 0 equals 0, then that's where instead you'll say that there are an infinite number of solutions. Okay, so let's look and see how we are able to use this to solve some systems of equations. So you recently bought awards for an end of year celebration. It tells us trophies cost $12. I'm going to let trophies be X, and medals cost $3. So I'm going to let medals be Y. It says we spent $60 in total and purchased a total of 11 awards. And then it wants us to write and solve a system of equations to determine the number of each that you bought. So let's first write our equation for how much we spent. So we spent 12 on each X plus 3 on each Y for a total cost of $60. We also purchased a total of 11 awards, so X plus Y must equal 11. Now, in the past, we would have solved this system by probably elimination, and we can still do that. However, it will probably be easiest if we go ahead and write this as an augmented matrix and then let our calculator do the work for us. So here would be our augmented matrix based on our system of equations. Let's go ahead and type that in. So if we hit second and then go into our matrix menu, let's go over to edit, and this time we're going to want a 2 by 3 matrix. In fact, I think I chose matrix A. That's okay. I'll just type my numbers over the top. So that was 12, 3, and then 60, 1, 1, and 11. So that's something else you can do if you don't want to make a whole bunch of matrices. Just find another one that's the same size and write over the top of it. So let's then go ahead and do our reduced row echelon form. So we'll do second matrix, over to math, choose our option for reduced row echelon form, and then we'll choose what matrix we want to use. Again, I type those into matrix A. You pick whatever matrix you used, and then here's our solution. So our reduced row echelon form was 1 and 3, and then 0, 1, and 8. So as an ordered pair, that would be 3, 8. In this context, X was trophies, so that would be that they bought 3 trophies. Y was medals, so they would have bought 8 medals. So you can see where this is kind of nice. You now are able to solve these word problems and these systems of equations without a whole lot of work other than just putting them into your calculator. Let's take a look at one more example of this. So you have 85 coins in nickels, dimes, and quarters with a combined value of 13.25. There are twice as many quarters as dimes. Okay, so I'm going to let nickels be X, dimes be Y, and quarters be Z. So our first equation that we can write, let's go ahead and write our system of equations first, then we'll use that to write our augmented matrix, is that we had 85 coins in total. So x plus y plus z has to add up to be 85. The combined value is 13.25. So nickels are worth 5 cents. So we would say 0.05x. Dimes are worth 10 cents. So 0.1y. And then quarters are worth 25 cents. So 0.25z has to add up to be 13.25. Finally, we have twice as many quarters as dimes. So the number of quarters z is twice the number of dimes d. In other words, z is equal to 2d. Now, you need for that to all be all the variables on one side of the equations. I guess I should have said 2y, not 2d there. Let me get that fixed first. So what you can do then is we can go ahead and move one of our variables over. I'm just going to subtract the z over and say that 0 is equal to 2y minus z. So as far as that equation goes, we would say that 2y minus z is equal to 0. And then don't forget, you are going to need a placeholder of 0x on the left-hand side. Okay, so let's go ahead and put these into an augmented matrix. So the first row would be 1, 1, 1, 85. The second row, 0.05, 0.1, 0.25, and 13.25. And then the last row, 0, 2, -1, and 0. All right, so then let's put those into a matrix using our graphing calculator. I'm just going to use matrix B since that's already a 3x4 matrix, and I will just type those over the top. So 1, 1, 1, and 85, and then 0.05, 0.1, 0.25, and 13.25. And then the last row, 0, 2, -1, and 0. And then again, look that over, make sure everything looks okay, and I think it does. So let's go ahead and quit out of that screen. Let's go back and find that matrix operation of RREF. We'll go ahead and select that that was matrix B that we typed those into. And then here is our solution. All right, so our new augmented matrix that we got using reduced row echelon form was 1, 0, 0, 25, 0, 1, 0, 20, and 0, 0, 1, 40. So as an ordered triple, our solution would be 25, 20, 40. And then thinking about what x, y, and z were, x was nickels, so we had 25 nickels. Y was dimes, so 20 dimes. And z was quarters, so we must have had 40 quarters. I don't know about you guys, but I remember those types of problems from like elementary school. They were always really hard. There's a lot of kind of guess and check to try to figure out what the correct answer was. And now we have this tool that's really kind of cool thing that we can do, not only with writing it as a system of equations, but now with being able to type it in as a matrix using the graphing calculator to make solving what used to be a really hard problem actually pretty easy if you think about it. All right, in the future videos, guys, what we're going to talk about is how matrices can actually do some of the same things that numbers can and that functions can, and that we can add, subtract, and multiply them. So we'll talk about that next time. Until then, have a great rest of your day.